Hello! In this video we're going to be dealing with similarity of triangles. Now I'm calling this similarity day 1 because we're just going to focus on triangles, and with that we are going to focus only on identifying them as similar. So that's all we're going to do. That's our only objective today, is just to be able to look at a couple triangles and see if they're similar. And I would like you to be able to make a similarity statement. So first things first, you have to know what the symbol is. That's our symbol for similarity. You probably recognize it because it's also a part of our congruent symbol. Our congruent symbol means same shape, and this means equal in size. So if you're looking at just the symbol for similarity, all that means is that we have the same shape. Okay, if two triangles are similar, then two things must be true. Two things. This is what you're going to have to remember for similarity. Just these two things. If two triangles are similar, then their corresponding angles are congruent. So it means your angles must be the same. Now there's something called the angle-angle similarity theorem. And what that states is if we have two angles from one triangle congruent to two angles of another triangle, then the two triangles must be similar. Think about it. The sum of the angles in any triangle is 180. So if two of the angles are the same, since the triangles add up to the same amount, which is 180 degrees, that third angle must be the same. Let me show you. If this is 60 degrees, and we know that in this triangle this one's 60 degrees, looks like these two angles correspond with each other. If this angle is 60 and this one's 60, again, that means these two angles correspond with each other. So what if I said, okay, I know I have two angles that are the same. What about this third one here? Well, according to that theorem, if two of the angles are the same, that third one, or that one in red, must also be the same. And here's why. If you add 60 plus 60, you get 120. 180 degrees minus the 120 means that this last angle must be 60. So that's going to have to be 60 degrees. Over here on this triangle, you're going to have the exact same situation. If one is 60 and the other one is 60, that's going to give you a grand total of 120. And 180 minus the 120 must be 60. So you get the same exact situation. So let me change this up just a little bit. Now this is not going to be drawn to scale. Alright, if I tell you that this angle right here is 50 degrees, and I tell you that this angle right here, up here is, we'll say 65 degrees, and this one's 50, and this one's 65, well, without doing any additional work, I know that the third angles must be the same. I know that this angle right here must be the same as this one. And again, here's why. 65 plus 50 is going to be equal to 115, and 180 minus 115 is equal to 65 degrees. That means this angle over here must be 65. Well, notice if we do the math on this smaller triangle over here, you're doing the exact same math problem. So it's going to be 65 plus 50 is equal to 115. You'd have to do 180 minus 115, and that's going to give you 65. You have the exact same mathematical problem on the other triangle. It's going to work no matter what happens over here. If you have two angles the same, then the third one has to be identical. So in other words, and this is totally not drawn to scale, if this one is 30 and this one is 70, Again, if this one were 30 and this one were 70, the third angle would have to be the same. It would have to be the same because 30 plus 70 is 110, and 180 minus 110 is going to be another 70-degree angle. Whoops. Did I just say that that 30 and 70 is 110? I was joking. That's going to be 100. So 180 minus 100. Whoops. Let's clear this. So that means that third angle is 80. And over here on this triangle, it's going to be the exact same situation. 70 plus 30. It's the same math problem. Is equal to 100. Oh my goodness. I've got that 110 in my head. I don't know why. So 180 minus 100 is also 80. It's the exact same math problem on the other triangle. Okay, so going back here, corresponding angles are congruent. And specifically with triangles, if you have two angles from one triangle congruent to two angles from another one, then they're similar. They have to be similar. Now, what if they don't tell you anything about the angles? Well, here's the other thing that's true. Corresponding sides are proportional. Okay, so let me share with you what that means. So corresponding sides would be proportional. Let's erase all this. All right, so what that means basically, let's say that this side is 5 and this side is 15. And this side were 5 and this side were 15. This side was 5, this one's 15. You should clearly be able to see the relationship between the two triangles. If I multiply this whole triangle by 3, then I'm going to get all those sides over there. So in other words, the big triangle is 3 times the small triangle in terms of its side lengths. If I take any two sides, any two, so let me choose a couple sides here. Let's choose this one. And let's choose this one. Oh, the marker's supposed to be red, but it's not. And I do 15 is to 5 as, let's pick another two sides, this one and this one. 15 is to 5. It should be the exact same ratio. Again, I can pick this third side right here. Is to 15 is to 5. Well, guess what? All of those are equivalent to 3. Sides are proportional. So now let's imagine that these sides were different and not an equilateral triangle. Okay, so if I told you that this side was, I don't know, we'll say this one's 4 and this one's 5. Okay, and I said this was 8 and this one was 10. And let's say this one was 3 and this one was 6. Would these two triangles be similar? And the answer to that would be yes, if you notice that the bigger triangle is actually double the smaller triangle. So our scale factor here is 2. This is nothing more than a dilation, and it's a dilation of 2. And your sides will be proportional. So in other words, this side corresponds with this one. So I could do 10 is to 5. So this one corresponds with this one. Let's color code this here. And this side corresponds to this one, so that's the same as 8 is to 4, which is the same as this side to this side, which is 6 is to 3. All of those ratios are all equivalent to 2. And by the way, if you were thinking, what if I wanted to do 5 over 10 and 4 over 8 and 3 over 6? Yep, it doesn't matter. The order in this doesn't matter. We don't care which one is being enlarged or which one looks like it's been shrunk. We just want to know if they're similar. Okay, so going back, there's two things that we're going to look at. Either the angles will be congruent or the sides will be proportional. So two things. Angles are congruent, sides are proportional. Let's try this. Okay, so in these problems, I want you to determine if the figures are similar. If they are, I want you to complete the similarity statement, and this is all you're going to have to do for your independent practice. So just this right here. So I'm going to model about 12 questions for you, and we're going to see how we do. Okay, first things first. If I look at this, honestly, it doesn't look like they're similar. This one kind of looks like it's a 90-degree angle. So my guess is probably that it isn't similar, but let's take a look. Let's get the sides that correspond with each other. So I'm going to say that this side right here must correspond with this one. So let's see. 89 is to 40. Now let's pick another side. How about this one on the bottom? So let's see, I put the bigger one on top over here. I should put the small one on the bottom. Okay, so big to small equals big to small, which would be 59. And I could also do the last sides if I want, and what I want to do is I want to see if it's going to be proportional. Now, what you can do is if you want to just stop with these two, do you remember how to see if these two are proportional? Well, you could simplify each one. It isn't obvious, is it? Or, with proportions, do you remember cross multiplying? So you would do 89 times 59, and let's see if it's the same as 153 times 40. So I'm going to pull out my handy dandy calculator and test this. Alright, so I just put this in my calculator and I got 5,251. And now I'm going to see if multiplying these two is going to be the same. So I'm going to do 153 times 40. So I'm honestly just using my phone calculator here, and I'm getting 6,120. So just with these two sides and not even doing this third side here, I can tell you that they're not proportional. So if they're not proportional, these two are not similar, and I can't finish the statement. Okay, let's take a look at number 2. Let's see. They don't really look like they're similar, but I'm not so sure. So let's take a look. Let's pick any two sides that look like they correspond, and here's the good thing. They only gave us two sides. They didn't even give us a third. So it looks like these two would go together. Okay, so let's make a proportion. You can put the 10 on top or you can put the 10 on the bottom. It doesn't matter. I'm going to do 49 is to 10. Now, if I do the 49 is to 10, then I'm going to say that 35 is to 7. Now already, I know that if I divide this, I get 4.9. If I divide this side over here, I actually get 5. They're not the same. But if it makes more sense to you to do this, which is to cross multiply, then do that. 49 times 7, we want to know if that's the same as 35 times 10. So we're just cross multiplying here. So I'm going to take my calculator here and go 49 times 7. And I got 343. And on this side, I got 350. They're not the same. This is not similar. So you can't even complete this statement. So there's nothing you can do here with that statement. This one doesn't tell us anything about the sides. So let's see if we can figure out if the angles are congruent. And this is going to take a little creativity. You're going to hopefully have to remember a few things. I can tell you that this angle right here is congruent to this angle right here. So if they don't tell you anything about the sides, let's look at the angles. I can tell you that those two angles are congruent. And here's how I know. They're vertical. Whoops, how about I spell it correctly? So the vertical angles. Now I don't know if you remember these symbols right here, but these symbols mean parallel. Oh boy, so here comes that parallel lines cut by a transversal. So if you have two parallel lines, so you got a parallel line parallel to this one right here, you've got a couple of transversals here. So if you don't see it, let's see. This angle right here is actually going to be congruent to that one. And the reason why is alternate interior let's get that pen back here. Alternate interior angles. Similarly, you've got this angle right here congruent to this one for the same reason. Alternate interior angles. So this angle is congruent to this one's congruent to this one, and this angle is congruent to this one. I would say that these are similar. So this is definitely similar. And we have to finish the statement. So KLM. So here's K. If K is first in this one, K is going to be first in this one. So I'm going to do triangle K. What corresponds with L? So what angle goes with the L? Well, hopefully you're looking over here going V. So V will be next. So KV. And what corresponds with the M? Well, that would be W, W. So I have to follow the same order that they gave me. All right, let's come over here to angle number 4, or triangles 4. All right, well, I can tell you that this angle is congruent to this one. Why? Because they're vertical. And they already told me that this one is congruent to this one. So these must be similar, because if two angles are congruent, then guess what? The third one must also be congruent. So let's fill in our statement. These are definitely similar. We have to follow the same order. So if U is first here, on the other triangle, U is going to be first on the other. So we're going to go triangle U. So you got to make the triangle symbol and then put the U. Now what corresponds with the V? Let's look. Angle V right here corresponds with angle Q. Look at the symbols. These two go together. So if V is second in your list, then Q must be second. So it's going to be triangle U, Q, therefore R must be last. So what that means is W goes with the R. And that would be true. The W definitely corresponds with the R. All right, let's keep it going here. We've got a few more to do. All right, let's see if these two are similar. Well, we don't really know anything about the angles. We do know that this angle is congruent to this one because they're vertical, but I don't know anything about the other two angles. So if I don't know anything about the angles, let's go with the sides. Okay, so 143 looks like it goes with or corresponds with the 55. Well, let's see. 143 corresponds to the 55. Is this proportional? Yeah, they're the exact same ratio. So these are definitely similar. So let's finish this similarity statement. So it says PQR. So P. Well, P is in both triangles, so triangle P. Now I have to figure out what goes with the Q. So which angle down in the smaller triangle goes with the Q? Well, that's going to be T. So that's P, T, and what corresponds with the R? So Q and T corresponds. Let's see what goes with the R. So the R actually goes with the S. So triangle PTS. Let's take a look at question number 6. 6 is interesting. They didn't really say anything about the sides. So if they don't say anything about the sides, we're going to have to go with the angles. Okay, well, this angle, angle A, is in both triangles. If you don't see the two triangles, you've got the big one here. So there's your big triangle, and then you have the smaller one that sits kind of on the inside of this one. So those are your two triangles. Okay, so hopefully you can see those two triangles. Angle A happens to be in both of them. So because angle A is in both of them, it's congruent. Now they also gave us another statement that's really important here to notice. They gave you these symbols right here. And hopefully you recognize those symbols. They mean these two lines are parallel. So if these two lines are parallel, then you have two parallel lines here and here cut by a transversal. Here's your transversal right there. So what this means, and you have to know your parallel lines cut by a transversal. This angle is going to be congruent to this one. It might be a little hard to see, but those two angles are definitely congruent. They are what's called corresponding. I don't know if you remember that terminology, but they are corresponding. And similarly, these two are in the same identical situation. Those two are corresponding. So therefore, you've got this angle, angle A, which is congruent in both, and then you got these two angles that are congruent, these two angles that are congruent. They're definitely similar. Okay, so A in the big triangle is congruent to A in the smaller triangle. What corresponds with B? Well, hopefully you're looking going, oh, it must be K. So since B is second, K must be second. And then what corresponds with the C? Well, that would be L. So AKL. All right, let's look at number 7. All right, I don't know anything about the angles, but I can look at the sides. So let's see if they're proportional. So I'm going to do 36 corresponds to 60 as, this is interesting. I can't really say 24 is to 60 because 24 is only this little part. So, and that's only part of a side of a triangle. That's not even the whole side. So, that's not going to work. So let's see. If this is 24 and this is 60, let's do 60 take away 24. Let's borrow from the 6 and let's make that a 5. So that means this is going to be 36. Oh, so then we've got 36 is to 60. So we've got this 36 is congruent, or this 36 corresponds with that 60. 36 to 60, yeah, they are definitely similar. The sides are proportional. These are the same ratios. Okay, so let's fill in the statement here. UVW, so that's our large triangle, is congruent to triangle, not congruent, I'm sorry, similar to triangle. Now if U is first, U happens to be in both triangles, so U is next. So now you got to ask yourself what goes with the V. So the V in this triangle is similar to the R in that triangle, and what goes with the W here would be your S. Done. Okay, let's look at number 8. Let's see. I don't have enough information regarding the angles. I don't. I only know this angle right here, and I know this angle right here. I don't know anything about these other two angles, so I can't use a similarity with the angles. So I guess I'm going to have to go with the sides. So let's see about the sides. Let's see, 20 over here looks like it would have to, now if this angle is congruent to this one, if I just turn this triangle up on the top here, if I were able to turn that, it looks like T and C would be the same. So this 20 goes with 24. And then this 20, so this goes with this. And this is going to go with this. Yep, they're the same ratio. So these two must be similar. Now look at this mess I made. Let me erase this because I made a huge mess. Let's finish our statement here. Okay, T corresponds with the C. So that means triangle C, since T goes with the C, what goes with the U? That would be D. And what goes with the V down here? Well, that has to be the E. Okay, so bottom line, when you're going through these problems, you know one of two things is going to be true. Either the angles are going to be congruent or the sides would be proportional. So one of two things. You're either going to be looking at the angles or you're going to be looking at the sides. So in this one, it looks like you would be working with the angles and the angles only. In this one, it looks like you would be doing the sides. So what I want you guys to do is I have some practice questions for you. All I want you to do is identify, are they similar? And you're going to do that once again by looking at the angles. Are the angles congruent or are the sides proportional? One or the other. You can't do both, you're going to do one or the other. And then you're going to finish your similarity statement. Okay, good luck with that. We will work a little bit further on that in our next lesson tomorrow.